Okay, so the next one is a little bit tricky. Meaning that, first, 5. Okay, so the next one is number 17, which is the limit of cos 2x minus 1 over cos x minus 1 as x tends to 0. Okay, now if you evaluate this expression at x is equal to 0, you'd get basically cos 2 times 0, which is cos 0. Cos 0 is equal to 1. 1 minus 1 is 0, and then again 1 minus 1 is 0, so you'll get 0 divided by 0. So you need to somehow basically evaluate this using some sort of method or some sort of trick, so that you don't get the 0 by 0. The way that you can do that, you know that basically, and basically somehow you need to get rid of these ones over here, because then you get some positive 1 over here, and you have a negative 1 over here, so this becomes 0. Again, you get a positive 1 over here, negative 1 over here, you get the 0 here. Now, you know that cos 2x is equal to 2 cos squared x minus 1, and that's equal to 1 minus 2 times sine squared x. And of course, it's also equal to some other things as well. For example, you can write it as cos squared x minus sine squared x, cos squared x minus sine squared x, or you can write it as 1 minus tan squared x, 1 minus tan squared x, 1 over 1 plus tan squared x. So these two are not going to be useful right now, but if I use this one, I can basically have a positive 1 over here and I have a negative 1 over here. Then I can get rid of this 1. So then I'm going to write this as the limit of basically instead of cos 2x, I'm going to write 1 minus 2 times sine squared x 2xx minus 1 over now cos x then is going to be using the same formula, 1 minus 2 times sine squared x divided by 2, because now I have the x over here, and half of that angle would be x divided by 2. X divided by 2 minus 1. The limit of this as x tends to 0. Now this 1 and this negative 1 cancels out, this 1 and this negative 1 cancels out, this negative and 2 and 2 cancels out. So you have the limit of sine squared x over sine squared x divided by 2 as x tends to 0. Now again, if you evaluate this expression at x is equal to 0, sine 0 is equal to 0, and again sine 0 divided by 2, which is the same thing as sine 0 is equal to 0. Again, you have this 0 divided by 0. So what you can do is that you can basically use that result that we had before, that we said that the limit of sine x by x as x tends to 0 is equal to 1. So I'm going to have to write these in this form, meaning that I'm going to write this as the limit of sine squared. Now over here you have sine x by x, so I have to write this as basically, this is a little bit tricky, you need to pay attention. So the limit of basically sine x, this is sine squared x, so I write it as sine x times sine x, and over here I have sine x divided by 2 times sine x divided by 2. Okay, and then I want to calculate the limit of this whole thing as x tends to 0. So I've just rewritten this thing down here. So then what I need to do is each of these parts has to be rewritten in this form. So I'm going to write this as the limit of basically sine x divided by x times sine x divided by x times over basically sine x divided by 2 divided by x divided by 2 times sine x divided by sine of x divided by 2 over x divided by 2. Okay, and then as x tends to 0. Of course there is something missing here, because I have basically, this is 1 over x squared. I have multiplied by the numerator. 1 over x squared I have multiplied by the numerator, and 1 over x squared by 4 I have multiplied by the denominator, so I have to take that out. So this is the same thing as 1 over x squared. Let me write it this way. This is the same thing as 1 over x squared over basically the reciprocal of this. 1 over this is basically 4 over x squared, which is the same thing as 1 over x squared times x squared over 4. So these two can cancel out and you will be left with 1 over 4. So that means that in total you have multiplied, overall you have multiplied 1 over 4 by this whole fraction. So I have to take it out, so I multiply this fraction by a 4. And 4 times 1/4 is equal to 1, which means that then I haven't changed anything in this fraction. Now, you see that I can basically write this limit as, first of all, I can take this 4 out, so I can write this as the 4 times the limit of this whole part over here, and then which is not working, I can write this as this 4 times the limit of basically sine x by x times sine x by x over sine of x divided by 2 over x divided by 2 times sine of x divided by 2 over x divided by 2, and as x tends to 0. And then I can write this as 4 times basically the limit of sine x by x times sine x by x as x tends to 0 over the limit of sine x divided by 2 over x divided by 2 times sine x divided by 2 over x divided by 2 as x tends to 0. And then I can write this as 4 times basically the limit of sine x by x as x tends to 0 times the limit of sine x by x as x tends to 0. And then this part over here, I can write the limit of sine. I can write the sine of x divided by 2 over x divided by 2. The limit of sine x divided by 2 by x divided by 2 as x tends to 0 times the limit of sine x divided by 2 over x divided by 2 as x tends to 0. And so you can see that this is equal to 4 times the limit of sine x by x as x tends to 0 is equal to 1. The limit of sine x by x as x tends to 0 is equal to 1. The limit of sine x divided by 2 by x divided by 2 as x tends to 0 is equal to 1. And then the same thing we have over here. So this is also equal to 1. So this is equal to 4. So that's how you solve this problem. So the next question that we have is the limit of, this is question number 18, the limit of ax plus x times cos x over b times sin x as x tends to 0. Ax plus x times cos x b times sin x. So as x tends to 0 here, the numerator becomes 0 and the denominator becomes 0. So you have to somehow take care of that problem. Now I can see how I can solve this problem. Okay, so about this one, so what I have found, I mean, of course you need to understand what is basically what is creating. Now if you, for example, if you evaluate this expression at x is equal to 0, you will get basically, so I can, for example, write this expression or this limit as the limit of, for example, x times a plus cos x over b sin x over b times sin x as x tends to 0. Now you can see that when x tends to 0, x over here in the numerator makes the whole numerator 0. And then sine 0 is also equal to 0, so then you will get 0 divided by 0. So now in order to avoid this situation, what you can do is that you can take this x to the denominator. Take this x to the denominator and write it as basically the limit of a plus cos x over basically b times sine x by x. So I take the x, the denominator, so I have to then put it over here in the denominator. And as x tends to 0. Now this is the same thing as the limit of a plus cos x as x tends to 0 over the limit of b times sine x divided by x as x tends to 0, which is of course equal to the limit of a as x tends to 0 plus the limit of cos x as x tends to 0 over you can take the b out, b times the limit of sine x by x as x tends to 0. Now you know that the limit of a constant function when x tends to any a basically, when x tends to any number is equal to the value of the function, or the value of the constant basically. So that's basically a. The value of cos x when x tends to 0 is equal to 1. Now the limit of sine x by x when x tends to 0 is equal to 1. So here you have b. So the answer is simply a plus 1 divided by b. This was number 18. Number 19 is the limit of x secant x as x tends to 0. So this becomes 0. This becomes 0, but not quite. Now secant 0 is the same thing as 1 by cos 0. So secant x is the same thing as 1 by cos x. Now cos 0 is equal to 1. So I suppose this is simply equal to 0. Let's see what the answer is. Number 19 is 0, just simply 0. Number 20 is the limit of sine ax plus bx, sine ax plus bx over ax plus sine bx over ax plus sine bx as x tends to 0, and here a and b, and here a and b and a plus b are not equal to 0. Okay, so basically you know that basically this bx is not a part of the angle. The angle that the argument of the sine function is basically only ax, not bx. I suppose that is so because then they have taken the ax out again and written it this way, and then you have sine bx over here. Meaning that in the numerator you have sine ax, in the denominator you have sine bx. Now, to solve this problem, basically when x tends to 0, of course sine 0 is equal to 0. So then your and then over here you get a 0 as well. 0 and then 0, so that's 0 over 0. Now, in order to solve this problem, what you can do is that you do need to write this as the limit of sine ax plus bx over ax plus sine bx over bx as x tends to 0. And since I have basically what I have done is that I have multiplied the numerator by 1 over ax, the denominator 1 over bx, which is the same thing as 1 over ax times bx, which is the same thing as bx over ax. So to cancel that out, so I have multiplied this whole fraction by bx over ax. So to cancel that out, I multiply this by ax over bx, which is simply a over b. So now I haven't made any changes to the expression itself. And then what I need to do is that I can write this as the limit of x tends to 0 of basically of this thing over here, sine ax by ax plus bx by ax over ax by bx plus sine bx by bx times a by b. And here x and x you can cancel out, here you have b. Okay, so I cannot do much over here right now. So you can write this as you can take this a by b out, meaning that you can write this as a divided by b times the limit of sine ax by ax plus b divided by a over a divided by b plus sine bx by bx as x tends to 0. And then what you can do is that you can write this as a divided by b, the limit of x tends to 0 of actually you can write it this way. You can write this as a divided by b times the limit of sine ax by ax as x tends to 0 plus the limit of b divided by a as x tends to 0 over the limit of a divided by b as x tends to 0 plus the limit of sine bx by bx as x tends to 0. And then you can write this as a divided by b. Now this is equal to 1 plus the limit of b divided by a as x tends to 0 is b divided by a, and this is a divided by b plus this is equal to 1. And so now you need to add these together, meaning that you can write this as a divided by b times a, so this is a plus b, a plus b, and the LCM over here would be b, a plus b, and so you can write this as a divided by b times a plus b divided by a times b divided by a plus b, which you can cancel these out, and then you can cancel this out, then you can cancel this out. This is equal to 1. So number 20 is 1. Number 21, you have the limit of cosecant x minus cot x. You have the limit of cosecant x minus cot x as x tends to 0. So cosecant x is 1 by sine x. Cosecant x is 1 by sine x, and sine 0 is equal to 0, so that's 1 divided by 0. That is 1 divided by 0, and cot x is basically sine x, cos x by sine x. Cot x is equal to cos x by sine x. This is 1 divided by 0. Now if x is equal to 0, then cosecant x is equal to 1 divided by 0, and cot x is equal to 1 divided by 0. So that's 1 divided by 0 minus 1 divided by 0. It seems that the limit is, I'm not sure if I'm right, but it seems that the limit is actually 0. But I'm not sure if that's the right way to solve this problem. So now to solve this problem, what you can do is let's take a look at the solution. Okay, it seems that it's actually what we said was kind of right, but you have to do some calculation here, meaning that you can write this as the limit of 1 over sine x minus cos x over sine x as x tends to 0, and then you can write this as the limit of x tends to 0, and then over here you have sine x, so you have 1 minus cos x, 1 minus cos x, and then basically we said that the limit of the limit of 1 minus cos x over x, we said that the limit of 1 minus cos x over x when x tends to 0 is equal to 0, and the limit of sine x over x when x tends to 0 is equal to 1. We proved these two basically results, and we can use them here. So I can divide both the numerator and denominator by x, meaning that I can write this as the limit of basically 1 minus cos x by x sine x over x as x tends to 0, and then I can write this as the limit of 1 minus cos x over x as x tends to 0 over the limit of sine x over x as x tends to 0 as x tends to 0, and this is equal to 0, this is equal to 1, so the whole thing goes 0 to 1, which is equal to 0. Okay.